Hello.
Hello.
Hello. I'm Jianbo and Inda and Fog. We are maintainers of Kubevela team. We hope to present something about Kubevela in this meeting, and we are in China. Due to the time zone, we are 0 o'clock here. It's late at night. So would you mind that let us to present first?
We are still waiting for the host, so to speak, and I don't mind, but we still have to wait for more people to come in.
Sure, of course.
Can you already say how much time you'll need for your presentation?
I think less than 30 minutes.
How long is that meeting scheduled?
It's an hour.
It's 20 minutes to 30 minutes.
Yeah, so no, so the meeting, the Tag App Delivery meeting is usually an hour.
Oh, I have another question for the meeting. Will this meeting be recorded? Because if possible, we would like to make some recordings for the presentation so that we can share it to the other community members.
I think this meeting is automatically recorded. Is that right, Thomas?
Yes, the technical things are always recorded.
Is it you who will manually upload it to YouTube, Thomas? Like, I think it's
Yes,
manual.
normally.
What?
This is a manual process, yes.
Okay, sure. Thanks for doing the work.
Let's give people 2 minutes to join.
Oh, nice to meet you.
Hello, everyone.
Hello. Okay, are we all here now? And do we still need to wait some people?
Yes,
Thomas,
please
will
please give the
probably
people 2 minutes to join, and then we can start.
Okay.
Okay, then let's start. Yes, hello everyone. Welcome to today's tech meeting. I think somebody already shared the meeting notes on the chat, and I think we have some kind of a perfect agenda today. So we have two presentations, one from QCTL and the second one from QVILA. It would be very nice if you could limit your presentations to 20 to 25 minutes. To give to the second project also the possibility to present in time. So let's start. I think the first one was QCTL. So the stage is yours.
Yeah, the QVILA guys asked to present first because it's quite late for them. I would be fine with that, but really if we can limit it to, you mentioned 20 to 25 minutes so that I get enough time.
Sure. Thank you.
Sure. Thank you.
If that is fine with the host.
For me, it's okay. So
Okay, then let's do it.
Very much appreciated. And Inda will represent us. Let's start.
So I can start now, and I will share the screen. Okay. Can you see my screen now?
Yes.
yes.
Okay, so let's start. Hello, everyone. My name is Inda, and I am one of the maintainers in QVILA. And today I will give a short presentation for QVILA, and I will introduce the features of QVILA and what QVILA can do, and some basic concepts of QVILA, and hope it will be clear for everyone to know that. Okay, so this presentation starts with a very simple question: is what is QVILA? So in brief, QVILA is a modern software platform that's targeting at delivering and operating applications across today's hybrid multi-cloud environments to make it easier, faster, and more reliable. There are several features that QVILA has to make the application delivery easier. The first one is that it is infrastructure agnostic. And as you can see in this figure, that QVILA did the application delivery, and the destination of the delivery can be various types. For example, the resources can be dispatched to Kubernetes multi-clusters, and it is also possible to deploy cloud services on cloud platforms, such as Microsoft Azure or Alibaba Cloud. Besides, it is even more possible to add some resources on edge devices with the integration with other open source projects, such as the OpenYARD or KubeEdge. And the second main feature for QVILA is that the QVILA platform and the QVILA system is highly programmable and extensible. It is achieved by leveraging a very powerful configuration language called QLang. So with this configuration language, we can make it possible to make abstractions to upper layer resources and organize them into an application. And for users that use QVILA, they can easily integrate their own capabilities through the QVILA add-on and write some simple Q scripts to integrate those open source projects into QVILA system as well, such as Prometheus, Istio, Terraform, Crossplane, and many others. And the third main feature is that the QVILA things are all application-centric. We developed a lot of features to make the application delivery more easier. For example, there is a QVILA workflow inside the application that can organize the details of the delivery process. And we have also other mechanisms, such as triggers and UI interfaces, which helps us to integrate with other continuous integration tools, such as Jenkins and other CI pipelines. And also we care about the day-to operating part. So it is also possible to leverage the observability services on cloud providers and use them to monitor the applications in Kubevela system. So here is a overview for the Kubevela part. And let's go into some more details. Okay, so the intuition of Kubevela is to solve some problems for users using cloud-native infrastructure. As far as we know that with the fast development of the cloud-native community today, more and more infrastructure capabilities are exposed to upper layer application developers. Although it makes it very powerful to design their customized application platforms. But for developers who mainly focus on the application logic, they need to care more about the details of the underlying infrastructure. For example, if someone wants to deploy a simple WordPress website on Kubernetes, he might need to know how to set up the storage or set up the gateway to help others to make its application accessible from the outside. And also, he might need to learn how to use the HPA and other mechanism to help it to make the deployment of the website high available. So there is lots of details for the infrastructure to know for application developers. And this will prevent application developers to focus on their own business logic, and they need to learn underlying knowledge of the infrastructure. So the complexity is becoming more and more critical for application developers. And another simple example is that when the underlying infrastructure changes, the application developer needs to know how to tackle these changes. For example, if the underlying infrastructure is the Kubernetes with version 1.21, the application developer might need to use the V1 Beta 1 ingress on this infrastructure and make its application to be accessible. But if the underlying infrastructure upgraded to 1.22, where the ingress version has changed to version 1, so at this time, the application developer needs to change its ingress to more latest version and then make redeployment of these resources. So that means the application developer needs to know how to handle the changes of the underlying infrastructure, and it is really complex for them to know. So how can we make this application delivery process more easier? So here is the open application model, which we have defined like 2 or 3 years ago. And the Kubevela is one of the implementation for this model. So with the open application model, we define a unified application specification, which provide interfaces for application developers to deploy their application. And from the left side of this slide, you can see that there is a simple application spec, and some of the web services are included in this application. And there are some scalar and gateway traits which describes how this web service should be deployed. For example, we might want 3 replicas and expose the port of 9898. But if you want to deploy the resources in Kubernetes manifests directly, on the right side, you can see that the user needs to write a lot of details for the deployment, the service, and the ingress. So the application model simplifies how users interact with the underlying infrastructure, and this is the major goal for open application model to do. And under the application, there are abstractions to the underlying infrastructure. And here we have the Qlang language, which provides some templates to do the abstraction job. And on the right side, you can see that there is a very simple abstraction to the underlying deployment, which exposes limited parameters for users. So if users want to use such workload in their application, they only need to specify the image fields, and then the underlying deployment will be automatically rendered and then dispatched to the cluster. So that's the application model, how it's work with the component. So with the QLang language, it is possible for users to make arbitrary extensions and to connect the application system with the underlying CRD system. Okay, so apart from the component part, we also have another thing is called trait. The trait is used to describe some auxiliary things that helps the component to work. For example, as we said, there is a scalar trait and the gateway trait, which defines how we scale out the replicas of the deployment and how we expose the services to outside. So the design of component and trait is actually a separation of concerns. So for example, if you use the scalar trait, although it can patch the replica fields in deployment, it is actually capable to modify various types of workloads, such as stateful set, or even other customized workloads, such as the OpenCruise clone set. So with this separation, different operation features can be divided into different parts, and the users can only focus on what they need to know. And so that we can reduce the knowledge application developer needs to know when they want to deploy their application. And here is a very detailed example for the gateway trait. And as you can see that there is limited parameters exposed to application developers. So they only need to specify the path and the port to use the underlying gateway trait. And the gateway trait can be attached to various workloads. And the ingress part can also be swapped with other implementations, such as the gateway API or the other things. And Kubevela platform mainly divides its users to two different parts. One of the part is what we commonly said is the application developer, which is indicated as the end users in these slides. And these users are mainly directly interact with the Kubevela application, and they write simple application manifests to specify how they want to deploy their application. And there is another part of people that focusing on building platforms inside the company. For example, they want to integrate with other capabilities, such as service mesh. They want to integrate the Istio or other advanced workloads, such as the OpenCruise. So they will use the definition, as we said, the component definition and trait definition. They develop those QLang-based definitions and integrate them into the Kubevela system so that the Kubevela system can be extended and gain more powerful capabilities, leveraging the open source projects. And also with the component part, there is not only Kubernetes resources can be defined in the application component. There are also some cloud resources that are also possible to make it in the component. So actually, you can specify which cloud services you want to use in component as well. For example, you can set up a relational database on Alibaba Cloud with the use of some types of component. And in addition to the hybrid environment, we can also to make the application to be deployed into multi-clusters. And the multi-clusters can be from various sources, such as the on-premise Kubernetes or some Kubernetes provided by the cloud providers. And here is how we specify the destination of application. For example, we can add some topology policy in the application spec, which specifies which clusters the application needs to deploy to. And also there are some advanced policies, such as the override policy, that can extend the capability of making multi-cluster deployment. Okay, after that, if you want to integrate more capabilities in your system, there is the Kubevela add-on. The Kubevela add-on includes the operator and the OAM definitions. So the operator are provided by the communities such as the Flux CD operator or ClickHouse operator, and they are embedded in the Kubevela application as well. And these add-ons also carries the OAM definition. So after you installed the Flux, for example, if you have installed the Flux CD controller in your Kubernetes cluster, so what you need to do to let your application developers to use Flux CD is that you can install some OAM definitions, for example, the Helm definitions, so that the application developer will be able to dispatch Helm charts in their clusters. So the OAM definition is the bridge that connects the Kubevela system with other open source projects. And we already have over 50 add-ons contributed in the community now. So if you want to directly leverage some existing capabilities, you can just use some simple commands such as Vela add-on enable and set up your development environment or some production environment. Okay, and the application delivery part, if you have installed such add-ons, it will be able to use those capabilities inside your application. For example, you can use the Terraform part to deploy cloud resources, and there is also Helm charts components that provided by the Flux CD or the Argo CD part, and there are also some Istio part and OpenCruise part. So you can make customized add-ons and install add-ons in your system to make arbitrary integration with open source projects. And so after we have defined what an application should contain, a more detailed question for Kubevela users is how to make fine control for its components. For example, some of the components might have dependencies inside, so we might need to deploy those component resources in some specific order. So that's how Kubevela workflow comes. In Kubevela, we also have a workflow that can control the fine process of the application delivery, where you can specify how to route your application, how to trigger a notification after your delivery is succeeded, and also you can promote your application delivery to multiple clusters inside your workflow. For example, you can dispatch to a development environment first, and after that, you can promote it to a production environment and send messages after it is succeeded. Okay, so the workflow part, as you see here, it is also back-ended by the abstraction layer, similar to the component part and trade part, which means the workflow step can be also highly extensible. And you can see from this architecture that the workflow part also leverages the X definition mechanism and uses some atomic functions provided by the underlying execution provider. And you can make different level extensions to the workflow part so that you can make just anything you want in the workflow steps. So after we have done with the application delivery, Kubevela also provides a unified day-to application management capability so that when the application is delivered, the application developer can monitor the status of the application and do the upgrade for different versions of applications. The most basic capability we provided is the resource management. For example, as the implementation for the operator pattern in Kubernetes, one of the native feature we have is that it can prevent configuration drift. Once the application have delivered the resources, it will watch the resource and see how it is changed. If the deployment, for example, if the dispatch deployment is modified by some malicious outsiders, the application will be able to observe that and then bring it back to the desired states. And we have also automatic garbage collection and resource sharing, which handles the resource management as well. So if the application is not do not need to use some resource anymore after upgraded, then the not in use resource will be deleted and recycled. And there are advanced policies that could customize those behaviors as well. And also, we have application version control that can to do some rollback and to do the history version recording. And also, it is possible to leverage some command line tools to inspect the different version differences between different application revisions. And finally, we also have the observability as Kuvela's first-class citizen. So there is a bunch of tools that could help Kuvela users to observe their applications. For example, in the command line, you can use the command line tools to do the interactive status inspect. And also we have a fancy UI interface if you want to interact with the browser instead of the command line. And on the browser, you can see the managed resources under the application, and there are also interactive ways for you to dig into the details of the resource if you really need to do that. And also, we can leverage some existing open source projects to help we build a very functional observability platform. For example, we can integrate the Prometheus server to provide metrics monitoring. And also we can have the Loki part to collect logs from the application and export those things to the Grafana dashboard and provide visualizations for the application. And one of the interesting things is that since Kuvela use the abstraction layer to make integrations, it is easy to for Kuvela users to customize the integration process. For example, you can customize how those logs should be collected and how the visualization should be plotted. So these are all the capabilities provided by the observability as code. And in addition to the customized observability, we have also some built-in system observability, which provide basic functions for Kuvela system operators to see the bottleneck of the overall Kubernetes system. And there is a bunch of tools in the Kuvela ecosystem that helps Kuvela users to build more functional application delivery platform. For example, if someone wants to build on top of Kuvela, we provided the VelaD project, which can build development environments fast and very easy. And also there is Terraform controller that connects the cloud resources to the Kuvela control plane. And there is cluster gateway to handle multi-cluster requests. And also we have separate the application workflow parts outside, which allows users to make even higher level orchestration among different applications. And Kuvela also cares about stability. And we have done several times of performance fine-tuning. And also there are load tests that can measure the bottleneck of the Kuvela system. And we have made some statistics under different environment. And there are different fields adopters in Kuvela. For example, there are commercial banks and car manufacturers that use Kuvela to build platforms. And there are also game companies and cloud providers that embed Kuvela as part of their services. And also the Kuvela community is very active now, and there are over 200 contributors from various countries, and thousands of issues have been raised by far, and most of them has been solved. And we also hold bi-weekly community meetings and upload the community meeting on YouTube as well. Okay, so that's a brief introduction for the Kuvela system and how Kuvela could help users to do the application delivery. And that's all for today's presentation. And if there is any questions, I am ready for answering for that. Okay.
Okay, so would it be okay for you if we do the question answer session more or less in an asynchronous way to edit in the target delivery channel or whatever, because we have to proceed with the second presentation.
Okay. So I will stop my sharing here. Okay, thanks for the presentation.
Okay, so thank you.
Yes, hello. I assume that I should take over now, right?
Yes.
To see second presentation. Okay, let's first share my screen. Can you see my screen?
Yeah.
Nice potato head,
Okay.
yes.
Sorry?
A nice potato head.
Yeah, that's kind of what it's about, partly. So let me first introduce myself. My name is Alexander Block. I'm a software developer, DevOps guy, and open source fan. And I've been working on a tool the last few years, which is concentrating on deploying stuff in a manageable fashion with multi-cluster, multi-environment support, templating, and so on. In the last weeks, I created a delivery scenario based on that tool. By the way, I didn't mention the tool's name. It's ClueCDL, cluecdl.io if you want to look it up. It's also on GitHub, of course. So I created a delivery scenario that tries to kind of showcase how it works and how it differs between other projects, for example, Kustomize or Helm or Flux and so on. I don't have a real presentation. I would prefer to just kind of do a live demo of that delivery scenario, and also allow to ask questions in between or give any comments or just tell me change that line and let's try that and stuff like that. So let's do it kind of on hands-on. So as you can see, it's the potato head demo that I'm using, having a delivery scenario. Let me enter the presentation mode. There we go. So this is the potato head project, having a subfolder ClueCDL now inside the delivery folder, and it defines a ClueCDL deployment project, which basically starts with a project definition, the cluecdl.yaml. By the way, can you also see these Zoom overlays here? Or is it just me who can see it?
No,
It's
only
that's
you.
just you.
Okay, great, because it's directly where I want to type. Great. Maybe I can remove it somehow. Do you know if that can be removed or moved or something like that? Okay, I have to look at that. Let me do this. Let me do this. This should work. So the idea is ClueCDL works on the base of targets. So maybe first, ClueCDL is a CLI tool. So you have a tool to control your deployments. And ClueCDL is a way to structure and define your deployments. A deployment means it's, of course, a bunch of manifests. It's a bunch of project files or ClueCDL deployment files and templating on top of that. All this starts with the cluecdl.yaml as the entry point. And what it does is it defines the targets that you want to deploy against. So
Am I muted? Yep.
Did you say something?
Thomas, you're not muted.
Oh.
Okay.
Okay. So instead of applying manifests to your current kube context or specifying which kube context you want to deploy to, the idea is that you define a target that defines all this. So for example, we can say we have a target with the name test, and we define that it should go through this context. We also define some entry point configuration called args or arguments. And we can have multiple of these targets. And the idea is that whenever you do the CLI invocations, you work based on targets. So you say, I want to deploy to test, or I want to deploy to prod, instead of saying, I want to deploy these manifests to this context with this configuration and stuff like that. So I said, this is the entry point. And when I later deploy stuff, it uses this as the entry configuration. Where to continue? The next thing is that you have a deployment YAML. Please ignore most of that. For the delivery scenario, I implemented a lot of stuff. What's important for us right now is the list of deployments. A deployment in this case is not a Kubernetes deployment. It's just like a deployment sub project or whatever. So it just means this folder should be deployed. So for example, we have the registry secrets. Okay, that's also a bad example to continue. Let's continue with the potato services. So what we have right now is it's an include, meaning we want to include a sub-deployment. A sub-deployment, again, contains a deployment YAML. And what this does is it defines multiple deployment items. A deployment item can be a customized deployment, or internally it could also be a Helm deployment, or it could just be a folder consisting of manifests. As an example, a very simple one, we have a customized deployment here, which is the namespace. Actually, it's just a bunch of manifests in this case. So it's just a simple manifest with templating. And that's where the target definitions come in play. So we are always assuming that we are deploying to a target. That means we have some entry point variables to be used. For example, the target, which has the name, and we also have the arguments that were provided to the target, and a few other things. So based on that, we include multiple such deployment items. Let's say what's below MISC, some config map. First, so the delivery scenario is based on the customize scenario that can be found in the same project. What I did is I used all these manifests and kind of tried to restructure them in a way I would do it with GlueCDL. So for example, not have everything in one folder, but instead do it in a way that, for example, everything that is hatch related is in one folder, everything that is entry related is in another folder, and so on. So let's use this one as an example. So we have the entry. So the deployment project defines we want to deploy this deployment item, which is the entry. In this case, it's a customization. It's just plain customize as you're used to it, with the difference that I could use templating here. I'm going to explain templating a little bit later. So it just adds a few resources, for example, the deployment entry, which is really just an nearly exact copy of the deployment I found in the customize deployment, with the difference that I'm using templating here for simple stuff. So that's basically how it's structured. You can do it as complex as you want or as simple as you want. The delivery scenario also shows the simple cases, which as shown is a customized deployment or just a bunch of manifests, or this one is getting a little bit more complicated, having the same deployment item included multiple times with different configuration values, for example. This is getting a little bit more complex then. So for example, I know there is the left leg and the right leg, but instead of having that 2 times, I just have it once, which is basically the same as found in the original customized deployment, with the difference that whenever there was left or right, I'm using the configuration value, which I'm providing through the include here. So that's the basic project structure. I realize that I'm a little bit unorganized right now. I hope I'm not opening too much. I hope that stuff is clear at the moment. Are there any questions so far? If not, I would just proceed to the demo, how to deploy it and how to use it and what it actually means to do it with GlueCDL. So no questions?
Yeah, I think it's pretty clear.
Okay.
So
let me start from scratch here because I already deployed everything. Just deleting some namespaces so that we can show it. So the idea is you just enter the project where the GlueCDL.yaml is located. And just based on that project, the GlueCDL YAML and all the deployments, sub-deployments, and deployment items, you basically have everything that you need to deploy it. So what you can do is GlueCDL deploy which target. That's what I explained. You always deploy 2 targets. For example, let's deploy to test. And what it does now is it renders the deployment doing all the templating stuff. Then it does a dry run and tells you how the dry run has gone. In this case, it shows errors because the namespaces are not created yet. But if I actually do the deployment now, the namespaces will be created and the errors will be gone. So it's asking me if I really want to do that. I'm saying yes. Now that I said yes, stuff is being deployed. And in K9S, we should see that everything is starting up. So what I did now is I deployed the test target. I can do the same thing with the prod target. Now maybe I should explain where the two targets differ. So maybe I first deploy it so that you see that stuff is actually being deployed twice. It's deployed twice in two different namespaces. And now the magic is that inside your deployment, you are using the, wait, am I in the wrong project? No, great. So you're using the GlueCDL project with the targets as the entry point, and it defines some entry point variables. You can do whatever you want here. It's just plain YAML that you can define here. Then inside the deployment, we include some variable files based on the entry point configurations that we provided. Some stuff is common. For example, let's say the replicas all set to 1 by default. We have lex by default, some other stuff. And then we, based on the entry point configuration, we load another configuration, which is also based on the templating that we use here. So in this case, we would use config / non-prod, for example, if we deploy to test, or prod if we would deploy to prod. So what happens is, first one, this one is loaded. Then based on that, this one is loaded, overriding or merging everything from this one into the first one, giving you a completely new templating context. So you can repeat that as often as you want. And everything that is then included as deployments, sub-deployments, or deployment items can then use a templating context. So as an example, we have defined the replicas here. That means because we have loaded it in the root deployment project, we can also use it in all sub-deployments, including the actual deployment items. So for example, we can use the replicas entry here as a simple template variable. We can override stuff. So if one is loaded first and then the next one is loaded, it can override stuff from that one. For example, by default, we have lex enabled, but for whatever reason, we disable lex on test. This will override the variable that was defined before and can then be used in whatever place you want inside your deployment project. For example, even in the deployment YAML, which kind of defines the structure of the deployment, you can use the templating to, for example, disable a complete branch of stuff that you'd like to deploy. And now that I have disabled lex for the test environment, for whatever reason I'm doing that, I can go back to the deployment, or to the CLI. And if I do a prod deployment now, I would expect that nothing would change because I haven't changed anything for prod. And this is what GlueCDL actually tells me. Nothing has changed. I could still try to deploy it, but nothing will happen. If I do the same for test, I should see that something has changed. In this case, it has realized, oh, there were some objects deployed before, which are not existing anymore. So it knows they are orphan, and it allows me to prune them by using prune. So I can clean up the deployment again, and we should see pods disappearing. So they are already gone, as it looks like. Let's do another example. Oh, I should close every other project. For whatever reason, it's always opening the wrong one. So let's do another example. Let's say on prod, I want to have 2 replicas for entry instead of 3. Yeah, so till this point, I had overridden it with 3. Now let's say I want 2 instead. If I deploy that to prod now, what it will tell me is what would change. I can now confirm or not, say yes, and it tells me what has changed. So that's why you see 2 diffs all the time. what's happening here is it's doing a dry run apply on the server side. So what you see here is actually what will happen. There's kind of a nearly 100% guarantee that this is the case. And what it shows you here is what really has happened. So before apply and after apply, and the diff between that. I'm also using structural diffs. So I'm not doing unified diffs, but instead showing the JSON path where something has changed and then what has changed there, which is a lot easier to read if you have hundreds of changes in your deployment for whatever reason. What else in regard to the delivery example? Yes, it turns out I'm a little bit unorganized today. Do you have questions so far? Is anything unclear? Nope. Okay. So where to continue? Another thing that I can maybe show is, which is not part of the delivery scenario, but possible with GlueCDL, is the use of Helm. So I've prepared it here. I have a Helm demo locally. As I said, it's not part of the delivery scenario that I created a pull request for. So I have a Helm integration here, which works by specifying what Helm chart I actually want. So the repo, chart name, chart version, release name, and what namespace to deploy it to. As you can see, even here, templating is possible. Basically, templating is possible everywhere, including the Helm YAMLs. So I can also do templating here. I use the pod info as an example to showcase it. Did some configuration here, as you can see. The idea with GlueCDL is that you should pre-pull Helm charts. So if you specify it, it's best is to pre-pull it. This happens by simply doing GlueCDL. I can hear myself for some reason.
Luis, your mic is on.
Okay, now it's better.
Okay.
So GlueCDL can work without pre-pulling, but I always suggest to do it because this gives the advantage of allowing you to add third-party Helm charts into a Git repository and actually knowing that nothing has changed externally without you knowing that it has changed. And also if Helm charts for whatever reason disappear, and it happens more often than one likes, you still have a copy of the Helm chart inside your source code, and it's a lot faster to deploy stuff if it's already part of your project. So if you have that, it's the same as with everything else, just do GlueCDL deploy. Let's say we deploy to test. And what you see here now is 2 new objects will be created, a deployment and a service. It again asks me, I'm fine with that, so I let it deploy it. I should see it appear now, and there it is. I will use some port forwarding to actually show that it's running. There it is. As I explained, yeah, so here you can see that it's pre-pulled. It's part of the project now, just below a subfolder. It's, as said, suggested to add it to Git, but you don't have to. What you can do now is, let's see what's configurable here. For example, Redis enabled or not enabled. Let me check. So let's enable Redis. This is a good example because if you are just able to do diffs based on Git, you would only see that some variable has changed, but you will not be able to realize what that actually means. Because enabling Redis doesn't just mean that something new is deployed, it also means that some configuration is happening in other stuff that is, for example, using Redis. So in this case, we will not just see that Redis is being deployed, new objects, but you can also see that some container is being reconfigured or some deployment, having a cache server being added. And now if I'm fine with that, I say yes, it does it, it restarts, and we see Redis running here. What else? I said the good thing is you can use templating everywhere, including the Helm values. You can ifs and elses here, which allows you, because there are examples, for example, Redis can be run in 2 different modes. One is the replicated mode and one is the non-replicated mode. If you configure it, or if you change that configuration, you also have to provide other values that you are not allowed to provide in the other case. So that means things might require either having 2 value files or just having a simple if inside your values file, allowing you to handle both cases in the same configuration. What else? Yeah, in the delivery scenario, I of course added a test.sh, added it to the GitHub workflow. So stuff is being tested automatically. It will download cluectl, create a kind cluster, and do different kinds of deployments to it. So it's basically the same as all the other delivery scenarios, so that it can be compared. This is, yeah. What else? Yeah, as I maybe have already shown, you can do prunes and you can also do deletes. So let's say we disable Reddit again and change the color to green. And if you do that again, the deployment, is this, oh, I should have increased the font size maybe. It's very hard to see stuff as I would assume. Wait, why is nothing happening? Where is enabled for? Oh, this is for prod. Okay, then. Did I already? Yeah, I used the wrong configuration file. So let's do a deployment against test again. So that's what I've shown in before already. So we again see something is changing for the deployment. For example, the configuration is being removed again. We also see that some objects got orphaned, meaning they are not part of the deployment anymore, but it knows that it was part of the deployment. So we can do the deployment, and after that do a prune to get rid of Redis, for example, because we don't need Redis anymore because for whatever reason we changed it. And then we should, yeah, Redis is gone. Should have done that already. What else? It's also possible to use cluectl without a cluectl project. So the complexity of a project, so the targets definition, and the deployment YAMLs is not necessarily required. You can also use a plain customized project, which I can show as well. So let's go into the unmodified customized deployment. And what you can do here now is just cluectl deploy without providing a target, because we don't have any targets right now. That means it will revert to the behavior that is known by people in the Kubernetes world. So it will just use the current context and the current namespace. So we are going to deploy the current customized project with the help of cluectl to the default namespace. And we should see it appearing in the default namespace. There it is. Now, the nice thing is we can use templating on a customized project now. Simply by, let's say, for example, whatever the entry. Let's make this one configurable. Let's call it entry replicas. It's actually args.entry replicas. And what we can do now is when we do the deploy, give it an argument, entry replicas, and set it to 3, for example. And we have the same behavior that you have seen before. We have the diffs, it does a full dry run. We can say yes or no. It will afterwards tell us what actually happened, which should be the same as what it predicted what will happen. And yeah, we got templating on top of customized now. What we don't have here now is pruning and deletion, because without the cluectl project, it cannot figure out which objects got orphaned and which ones not. Yeah. So let's change it back to one replica and so on. Okay, I think I covered most of that in a very unorganized way. I'm sorry about that. There is a YouTube video that explains it a little bit more and better in a more organized way. I can post it if you, or you can look it up if you go to the raw code Academy channel, which explains it a lot better. So yeah, that's it. Oh yeah, as you can see, it has changed to green. It was blue before.
Okay, so I
Yeah,
think
any
you already raised a pull request for this in the potato repository, right?
Yeah, exactly. So that's everything that I've just shown now is part of the delivery scenario that you can see in the Potato Head project. So it's easily comparable to all the other stuff. Yeah, I'm waiting for reviews and questions and feedback and so on. One other thing I can say is all this is so what you've seen right now is not GitOps, but it is completely compatible to GitOps. So you can do whatever style of GitOps you want. You can run it in a pipeline. You can also run it through a controller. There's a Clustdl controller available where you have a custom resource that defines your Clustdl deployment, that defines which target to deploy and which arguments to provide. And then it can handle everything that you like. The idea is that whatever you do, you can always switch between modes. You can do the GitOps style, for example, on prod, but still do a dry run or a diff on prod before you push something. Or you can revert to working completely from the CLI in dev environments, all based on the same project definition. Everything is exactly the same. And then let GitOps take over whenever you are going to the next environment, for example, to the test or the prod environment or whatever you like. At the same time, if you, for whatever reason, realize stuff is broken on prod, I need to act immediately, you can still do that because you can go to K9S and do whatever fix you need to do. I mean, it's bad, it's evil, we all know that, but it happens. And the good thing is that if you use a correct field manager value, cluectl will respect that, no matter if you're using GitOps or from the CLI, because it's completely relying on server-side apply. I also created a blog post a few days ago. Actually, it's already 2 weeks ago on the communities.io blog, describing how I use server-side apply in cluectl and how it allows to kind of let everyone live and let live using GitOps, not GitOps, pipeline ops, whatever they like. I also created a CNCF sandbox application. There is an issue in the CNCF project, sandbox project, and I'm also waiting for review and feedback on that. The project is still very fresh. I'm the main, actually the only maintainer doing most of the contributions. I hope it will get some traction and also bring other people to contributions. I hope that other people are going to use it. I mean, as said, it's very early. It means it is some risk for people to actually start using something like that because you don't know where the project will go, of course. But I think it is already stable enough that you could use it in production without having too much risk. So yeah, that's the current state.
Okay, then thank you for the presentation. One question which I would have is why should I choose cluectl instead of Helm?
Yeah, I believe that it's one of the most.
Just a question which came into my mind.
Yeah, it's one of the questions that always comes up, because it does much more than Helm does. it's yeah, how to explain it? I think that the way you can structure your project and the way you can work with configuration allows you to handle much larger deployments. So on one side, you can have a very simple deployment. For example, the potato deployment is a very simple one, having just a little bit of configuration, but you can also have very large deployments with a lot of configuration from different sources. I have just shown, for example, the file as being the configuration source. Actually, I have shown two sources of configuration. One is the args, so kind of the entry point. And based on that, I loaded more configuration. And based on that, I could even load configuration from other Git repositories. I could load configuration from the cluster itself, and so on. So I believe that the way you can structure your project aligns more with what you need for large deployment projects, and also for multi-environment and multi-cluster deployments, because it gives you a lot of tools and options to do that in a convenient way. As an example, if you encounter a CluciDL project in your company, because you just started there or because you have to take over a project, you just have to know which targets exist, because whoever has created that project has already perfectly defined how to deploy that, because he defines the target, he deployed the configuration required for that. And in one of the next versions, it will even allow you to ship the kubeconfig in a ZOPS encrypted way.
My question would be, this is Alex here, co-chair of the tech. Sorry for being late today, but there was an emergency.
Yeah.
How would this, for example, work in an environment where I'm already running Argo and have my application sets already defined? So that more or less gives, you might have also like some of the target definition that you have right now also maybe in a GitOps tool already set up.
So I have looked into Argo integration. Turned out to be much harder than I wished. I'm not sure if I will be able to have an Argo integration, because the architecture of Argo makes it very hard to integrate something like CluciDL. They have the plugins, but the plugins require you to just write out some manifests and then give full control to Argo about the manifests. And that's not what CluciDL is doing. CluciDL wants to, or actually needs to deploy all this stuff with its own implementation for all the features to work. There's a lot of stuff that you can control through annotations, for example. You can do a lot of conflict resolution just by defining, just by setting annotations on objects. You can, so it wouldn't be compatible to something like Argo CD. Flux, on the other side, is easier because Flux implements everything in its own controller, which just means that I have to implement my own controller, which I already did. So there is a Flux CluciDL controller that does Flux deployments, that does CluciDL deployments in the Flux style. So you can do that. It of course means that you cannot use plain customizations from Flux anymore. You would have to switch to CluciDL deployment custom resources, which then reference your project and all the configuration. Yeah.
I just wanted to know how it plays together with GitOps based approaches. Because you mentioned
as I said, GitOps is easily possible, but probably not with the existing tools. It's easier with Flux, but it will be hard with Argo CD. If they ever decide to change their architecture, that they allow to give plugins or whatever they will call it at that point, more control about the deployment process, I can consider implementing it into Argo. Until then, I don't see how I'm going to implement that.
Yeah, because that might be a question that's actually also coming up during the sandbox process as well, how well it plays together with other tooling, and they're not meaning that it needs to play well together with all the other tooling. But that might be something to think about.
Yeah, yeah, I'm aware of that.
People, I mean, you don't have episode of CNCF end user report that also mentions GitOps tooling, and Flux and Argo are widely used with the community. And I think it would be good to have an answer. What should I, if I'm already using Flux, so if I have for the company, I've either decided to use Flux or Argo, what would it mean to combine these two together? Even if it's not implemented, at least having an idea on a roadmap, I think would be helpful for people.
So generally, I mean, you can use both at the same time. You can even use Flux and Argo at the same time. So nothing stops you from also using CluciDL. What I try to use an argument is, if you decide to go for Flux or Argo, you make a decision that means that you fully go with Argo and Flux. Because if everything is deployed through Flux, then everything is going to deploy through Flux. You cannot, for example, decide to have a dev environment deployed from the command line, because you would always have to do it in the Flux style. You understand what I mean?
Not really, because Flux only specifies where it finds the Git repositories. But
yeah, and
if you deploy it via kubectl or via Flux.
True, but at the same time, it adds features to Kustomize, for example, substitutions, which Kustomize doesn't support natively. If you start to use that, and I would say that many people are using that because it makes Flux very powerful, then you lose the ability to easily use Kustomize from the command line. The same for Helm. If you start to use the Flux features, you kind of get locked into Flux. And I assume it's the same for Argo CD. I didn't look too much into Argo CD in that regard, but I assume it's the same. So if you end up with complex deployments using all the features from these GitOps tools, you will be completely dependent on GitOps. And that means for every environment, at all times, you will have to rely on Flux. I think it's a lot of value if you are still able to kind of revert to other workflows. For example, doing the exact same deployment from your console, from the CLI. As an example, we have environments that we run in a special mode in prod, where the GitOps part is just replacing images. It's the only thing it does. So it doesn't touch the infrastructure related stuff. If you do large changes, for example, introducing some new way how stuff is communicating, and I would have to make up an example now. We can mix that, so we can let the GitOps style keep replacing images, and when we feel ready, we can use the CLI to do the full-blown upgrade, which can break, and which can mean that you have to do manual interventions at that point in time, and so on. So having the option to go both routes at all times, and in my opinion, it's very valuable.
Mm-hmm. Yeah, I think
We're already over time.
Yeah, I mean, I have time. It depends on you, or is there a hard limit on these meetings?
No, maybe we'll also have the recording available that we can more broadly share it with people who could not join it today. Also, if you want to have another recording to be shared, because you mentioned one before, please just let us know as part of the meeting docs, and we can also like reshare it with the wider community.
Yeah, I can look that up. See YouTube video.
It's in the chat window.
What do you mean?
The meeting notes in the chat window. So if you want to add another.
So just add it to the meeting notes.
Yes, just add it in there if you want. Because
okay.
obviously this one, but you mentioned before that you have another one which you might want to share, so we can also share this one as well.
Yeah, I'll edit there. Yeah. Okay.
Thank you.
Okay, great. Thank you.
Okay. Yes, then thank you for everyone who presented today. As we said before, we are already out of time. So I think the next meeting is in around two weeks. Mm-hmm. There we also have some presentations in the schedule at the moment. Yes, it would be nice if you would join the meeting also in 2 or 3 weeks. And yes, with this, have a nice morning, evening,
Rest of your day. We're
Rest of your
all time zones. Rest of your day works because we're all in the middle of the day somewhere. All right. Bye.
Sure.
Everyone.
Bye.
Okay. Thank you. Bye bye. See you.
Thank you.
Thanks,
Bye bye.
Bye.
I thank you for your time.